Venus, the so-called sister planet of Earth, is, paradoxically, the most hostile world in the solar system. Its surface is hot enough to melt lead, its atmospheric pressure could crush a submarine, and the sky, thickly cloaked in clouds of concentrated sulfuric acid. Yet it was precisely this brutality that became the relentless challenge and obsession of the Soviet Union over 3 decades. From the early lost ventures of Venera 1, 2, and 3 to the historic success of Venera 13, the first craft to land on Venus, surviving 127 minutes on that infernal surface, sending back images, sounds, and chemical data never before captured. In 2012, a Russian scientist claimed that photographs from Venera 13 revealed a creature moving across Venus's surface. Although the scientific community dismissed this finding, it left a lingering question. Did the Soviets actually see something extraordinary on Venus? In this video, we rewind the clock and step into the Venera journey, where science, politics, and mystery collide. The Soviet Union's exploration of Venus through the Venera program was a relentless battle against the physical limits of matter and engineering. Venus, with its super dense atmosphere, surface temperatures soaring to roughly 470 degrees Celsius, hot enough to melt lead, and pressures comparable to 92 atmospheres beneath Earth's oceans, became the harshest laboratory humans had ever attempted to conquer. Early Soviet attempts met with failure. The Venera probes 1, 2, and 3, launched between 1961 and 1965, could not complete their data transmission missions. Engineers quickly realized that standard designs were insufficient to protect delicate electronics from the planet's extreme heat and crushing pressure. Venera 3 became the first human-made object to impact the surface of another planet. But its inability to send back any data underscored the fact that surviving on Venus required not just landing, but a breakthrough in structural engineering and material science. The first major turning point came in 1967 with Venera 4. For the first time, a probe could descend into Venus's atmosphere while transmitting data throughout its entry. Venera 4 provided the first quantitative, direct measurements of atmospheric composition and structure. A technical triumph, but it was ultimately crushed by the planet's pressure before reaching the surface. The pinnacle of engineering success arrived with Venera 7 in 1970. Soviet engineers completely redesigned the lander module into a super-strong titanium sphere, reinforced to withstand pressures far exceeding initial estimates. This craft was built like a space submarine, with sensitive instruments packed safely inside a thick, pressure-resistant shell. Though it operated for only a brief 23 minutes. Venera 7 confirmed the planet's surface conditions and proved that human engineering could endure such extreme environments. In 1975, Venera 9 and 10 achieved another milestone. They sent back the first black and white photographs of Venus's surface. These images revealed for the first time a concrete landscape. Sharp, cracked rocks under a hazy yellow-orange sky, caused by the scattering of light through thick sulfuric acid clouds. Designing an optical system that could function under Venus's extreme temperature and pressure was an engineering feat far beyond the capabilities of any other nation at that time. The crowning achievements of the Venera program came with Venera 13 and 14 in 1982. Venera 13 set a record by surviving on the surface of Venus for 127 minutes. A period that seemed brief to us but represented a remarkable endurance under the planet's harsh conditions. During that time, it performed invaluable scientific tasks, capturing the first color images, revealing detailed views of gray-brown rocky terrain and a fiery orange sky. For the first time, humanity heard the sounds of another world, the faint whistling of wind through the dense atmosphere. Using a specialized drill, it collected surface soil samples and analyzed their chemical composition with X-ray spectroscopy, providing foundational data on Venus's geological history. If the technical achievements of the Venera program were a bold declaration, then the data it returned were a whispering mystery, a portrait of a forsaken world. For the first time, humanity glimpsed the surface of Venus, and what emerged was not only harshness, but a cascade of unanswered questions. The Venera probes 9, 10, 13, and 14 delivered historic images. These were not beautiful pictures, they were striking snapshots of a deadly world. Bathed in the dim orange-yellow light filtered through a dense atmosphere, the terrain appeared barren and desolate, far beyond what scientists had anticipated. Most striking were the sharp-edged rocks and fractured boulders. scattered across a surface seemingly coated with thick dust or sand. The existence of razor-sharp edges on these rocks remains a profound mystery. On Earth, wind, water, and other erosive forces quickly wear down sharp rock features. On Venus, though there is no liquid water, the super-dense atmosphere behaves like a powerful fluid, generating winds strong enough to cause erosion. So why do these boulders retain their knife-like shapes? This implies that the geological processes that broke or formed these rocks occurred recently, or that some physical, chemical mechanism on Venus's surface is counteracting erosion. Decades later, the rare direct images from Venera still harbor unexplained signs. Some researchers, including former Soviet scientists, have pointed out unusual shaped objects appearing and disappearing between consecutive photographs of the same landing sites. Are these technical glitches, debris from the landers, or something stranger? The most intriguing hypothesis comes from a few scientists who speculated that the geometric structures or transient objects captured in the images could be evidence of the survival of some extreme form of life. Although the scientific community largely dismisses this possibility due to the planet's unbearable temperature and pressure. The curiosity persists. What caused the strange spots or faint lines in Venera 13's color images? Today, we cannot easily land probes on Venus, but technology has advanced in another direction: remote observation. Advanced space telescopes, like James Webb, alongside radar missions from NASA and ESA, have returned to study Venus. James Webb, using specialized infrared wavelengths that can penetrate certain cloud layers, investigates the chemical composition of the atmosphere and even surface reflectivity in the regions previously explored by landers. Modern radar tools, particularly the radar from the Magellan mission, have provided detailed topographic maps of 98% of Venus's surface, identifying volcanoes, plains, and massive tectonic cracks. What Venera captured, a faint dust layer and razor-sharp rocks, remains uniquely irreplicable by radar. Scientists are working to use this data to accurately decode which materials create the unusual reflectivity that radar and JWST detect, especially in elevated terrains. This makes the images from the 1970s more valuable than ever. They are surviving fragments of a vast puzzle. a reminder that we have only just begun to touch the edge of Venus's mysteries. While the scientific data from the Venera missions overwhelmingly indicate the impossibility of life on Venus's surface, a sensational claim emerged decades later, challenging the scientific consensus and sparking public curiosity. This is a story about how low-resolution images, captured under extreme conditions, can be interpreted in multiple ways. In 2012, Dr. Leonid Kazanfomolity, a veteran scientist from the Russian Space Research Institute, who had directly participated in the Venera missions, published a controversial finding. Reanalyzing images taken by Venera 13 in 1982. He claimed to have detected objects that appeared to move and change shape between consecutive frames taken minutes apart. Most strikingly, Kazanfomolity pointed out a complex-shaped object resembling an arthropod, appearing in one frame and vanishing in the next. He suggested that this could be evidence of an extremophile life form capable of surviving Venus's extreme temperatures and pressures. Perhaps through a physical or chemical structure entirely alien to Earth-based biology. However, the international scientific community almost entirely dismissed this claim, attributing it to misinterpretations and technical artifacts. The Venera images were extremely low resolution and underwent heavy compression to transmit across interplanetary distances to Earth. Faint details and ambiguous shapes were easily misread. The most widely accepted explanation is that the object was merely a protective shell, or a piece of equipment dislodged from the Venera 13 lander during descent. The apparent movement could have been caused by wind or minor shifts of the lander itself. Human brains naturally seek familiar patterns, especially shapes resembling humans or animals. The arthropod could simply have been a rock illuminated to create a scorpion-like illusion. The debate reignited in 2020 with a groundbreaking scientific announcement: the detection of a significant concentration of phosphine gas in Venus's clouds, about 20 parts per billion. Phosphine is a toxic gas that, on Earth, is primarily produced by anaerobic biological activity or industrial processes. Analysis indicates that no known chemical or physical process, volcanism, lightning, or mineral reactions, could generate phosphine at the observed concentrations in Venus's atmosphere. This makes phosphine a potential biosignature. suggesting that an unknown microorganism may exist and thrive in sulfuric acid droplets. Using an extraordinarily unique energy metabolism to produce phosphine as a byproduct. Despite the compelling evidence, skeptics have pointed out two nearly insurmountable chemical and physical barriers: water activity and acidity. Venus's clouds contain no liquid water, only concentrated sulfuric acid droplets. To survive, any organism would need a protective shell or an entirely novel chemical mechanism capable of replacing water as the main intracellular solvent. A phenomenon never observed in Earth-based biology. Perhaps the greatest barrier is the extreme scarcity of free water. While sulfuric acid contains water, most of it is chemically bound. The available water for biochemical reactions in Venus's sulfuric acid droplets is extremely low. For comparison, even the most drought-tolerant organisms on Earth require an AW of at least 0.585 to maintain enzyme and membrane function. Venus's environment is hundreds of times drier than the survival limit of any known organism. To reconcile the presence of phosphine with Venus's harsh environment, scientists have proposed bold biological models. One hypothesis suggests that microbes may survive in the clouds, but when carried downward into hotter, more acidic layers, they enter a dormant, spore-like state. High winds then return them to milder layers, where they reactivate and reproduce, creating a continuous survival cycle. An even more extreme hypothesis is that Venusian life may have evolved a biochemistry not based on water as the primary solvent, possibly using concentrated sulfuric acid or another compound to form stable structures resistant to corrosion. New missions, especially NASA's Deep Atmosphere Venus investigation of noble gases, chemistry, and imaging, will deploy probes into the atmosphere. The mission's primary objective is to precisely measure phosphine and trace gases, along with analyzing the composition of cloud droplets and H2O at different altitudes. This analysis delves deeply into why the cloud layers are considered potentially habitable and the chemical barriers any life form would have to overcome. Studying Venus cannot be separated from the study of moving objects in the solar system, as both serve as prime examples of physical interactions in extreme environments. Comics like Atlas become invaluable references. Atlas is a remarkable example of how icy material interacts intensely with its surrounding space environment. As it approaches the Sun, it is influenced not only by gravity but also by electromagnetic radiation and solar wind. One of the greatest challenges for settling Mars is the lack of a global magnetic field and a thin atmosphere. Leaving the Martian surface exposed to high doses of dangerous ionizing radiation. By contrast, Venus offers natural shielding. The atmospheric density at around 50 kilometers altitude is sufficient to absorb most high-energy particles. Radiation levels there are estimated to be comparable to or lower than what astronauts experience aboard the International Space Station in low Earth orbit. This eliminates the need for thick, heavy, and expensive radiation shielding such as rock or water layers used on Mars, significantly simplifying module design and construction costs. Gravity differences are a critical factor for the long-term survival of humans in space. Surface gravity on Mars is only about 38% of Earth's. Prolonged low-gravity or microgravity environments cause severe biomedical issues, including muscle atrophy, bone loss, vision impairment, and immune system changes. On Venus, settlers would experience an environment nearly compatible with human physiology, greatly reducing health risks related to bones and muscles, making Venus an optimal biomechanical choice for permanent settlements and human reproduction in space. At the 50-kilometer altitude, temperatures range between 27 degrees Celsius and 37 degrees Celsius. The pressure is near 1 atm, a major engineering advantage. Floating structures do not need to withstand large pressure differentials. Instead of designing rigid pressure suits or modules capable of withstanding extreme pressures. Settlers would only require cabins equipped with chemical filtration and basic respiratory support to protect against sulfuric acid vapors. Because breathable gas is much lighter than the surrounding atmosphere. A massive balloon filled with breathable air could generate significant lift, allowing it to float and maintain altitude without continuous energy expenditure. The greatest engineering challenge lies in composite material design for the balloon's shell. The outer layer must meet three simultaneous requirements: resist concentrated sulfuric acid in the clouds, handle structural loads and high-speed wind forces, and withstand degradation from intense ultraviolet radiation, especially at higher atmospheric levels. Teflon or high-grade fluorocarbon polymers are the top candidates. Kevlar or carbon nanotube composites would be integrated to withstand structural loads and strong winds. Venus's potential for future exploration extends beyond the solar system. Venus serves as an ideal model for studying Venus-like exoplanets, particularly tidally locked worlds. Venus is a textbook example of a planet that has surpassed the water evaporation threshold and become trapped in an irreversible thermal loop. Studying noble gases and hydrogen isotopes in Venus's atmosphere through missions like Da Vinci Plus is key to understanding exactly how a once habitable planet transitioned into a hellscape. Venus's superrotation mechanism enabled scientists to model heat and energy transfer on tidally locked exoplanets. On these worlds, the day side is scorching while the night side is frozen. Superrotation distributes temperature evenly, showing that a dense atmosphere can act as a self-regulating mechanism, making the habitable zone on tidally locked planets more temperate. In summary, Venus is not just a destination, it is a cosmic control station, where advanced engineering challenges will open the door to humanity's long-term habitation of the galaxy. Looking back at the journey of exploring Venus, we can see that the Soviet Venera missions achieved a true milestone. Becoming the first human-made objects to successfully land on the surface of another planet. From this, we understand that Venus serves as a natural laboratory of extreme chemistry. Its thick sulfuric acid clouds, acid rain, and carbon dioxide-rich atmosphere have transformed the planet into a blazing furnace, a stark contrast to the planet's primordial beginnings. The Soviets once claimed to have observed moving structures resembling life in the old Venera images. But the international scientific community largely dismissed these as technical errors caused by image interference or rock formations eroded by wind. Recently, however, the discovery of phosphine, a potential biosignature in the cool upper clouds, has reignited the debate over life on Venus. Venus, our enigmatic second home, is poised for rediscovery. with upcoming NASA missions such as Da Vinci Plus and Veritas, we will, for the first time, send probes flying through its clouds to analyze and map its geology in unprecedented detail. Tracking these missions is not merely a scientific endeavor, it is an effort to probe the boundaries of life itself, to uncover the mysteries the Soviets left behind, and, most importantly, to gain insights into climate processes that could help us protect our own Earth Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.